Now that we've covered the basics in the previous video, now we're going to actually look at graphing using slope-intercept form. So step 1 is to put the equation in the correct form by solving for the y. And this is only if it's necessary. So looking at our example over here to the right, 2x minus 3y equals 3. This is not in slope-intercept form. Therefore, it is necessary to get it into that form. So that's going to be our first step. We're going to take 2x minus 3y equals 3, and we're going to solve it for y. So the first thing we're going to do is we're going to subtract our 2x from both sides. That gives us negative 3y. Be careful to bring down the negative. That is a common error. And then minus 2x plus 3. Okay, make sure that the 3 is positive and the negative goes on the 2x. And then our last step is to divide every single term by negative 3. So that gives us y equals negative 2 over negative 3 is a positive 2/3. So again, we want to keep this as a fraction, and then the x comes to the side because 2/3 is the coefficient. We want to keep it somewhat separate. And then positive 3 divided by negative 3 is a negative 1. And make sure you write it the negative. Again, common errors here. Now, once we've got it into slope-intercept form, the second step is to graph the y-intercept. And it's important to remember that the y-intercept is a point. So step 2, identify the y-intercept. So here the b equals negative 1. So what that means is that we have a y-intercept of 0, negative 1. Okay, so 0, negative 1 is going to be on the y-axis. And that's why it's called the y-intercept. It will always be on the y-axis. So if it's on the x-axis, you've done something wrong. Step 3 is to then use the slope to find additional points. So step 3, our slope in this problem is 2/3. So this can be written as positive 2 over positive 3, or negative 2 over negative 3. Remember, if it's positive, then there's going to be the same signs on top and bottom. So if I use my slope, I could go up 2 from this blue point, and then right 3, or I can go down 2 and left 3. And then our final step is to draw a line through the points. Again, this is assuming the domain is all real numbers. And since there's no domain on this function, it is all real numbers. And then we're going to draw our line and put an arrow, again using a ruler so your line is much straighter than mine. Okay, and that is how you graph using slope-intercept form. Now again, there's a couple of quick checks you can make. Definitely check to see if your slope is positive, and it should be rising from left to right. Check to make sure your y-intercept is negative, so on the bottom. You can also check some points into the original function, because if you solve the function incorrectly, then you're going to graph the line incorrectly. So you could try plugging in 0, negative 1 up in our function to see if it equals 3. If it does, then you've most likely done something correct. And then you can do the same thing with a point 3, 1, or the point negative 3, negative 3. Plug those points in to see if they work to make sure the line is correct. Alright, number 9, we have y equals 4x minus 2. Now this is particularly nice because it's already in slope-intercept form. So we don't have to solve this one for y. So the first thing we're going to do is identify our y-intercept. So our y-intercept here is going to be the negative 2. So that's going to be 0, negative 2. So we're going to plot 0, negative 2 down here on the y-axis. Then we identify our slope. So our slope is going to be 4. And again, this is positive, so that means this is going to be positive 4 over positive 1, or it's going to be negative 4 over negative 1. So if we go up 4, 1, 2, 3, 4, and then right 1, or we could go down 4 from the red point, but we don't have enough blocks. So we can only get these 2 points on this graph, and that's okay. As long as you have 2 points, you can draw a line. So we're going to simply draw a line through these 2 points. Again, using a ruler so that our lines are nice and straight, and then put arrows on both ends, and that's it. So let's look at number 10. 2x minus 2y equals 0. So the first thing we want to do here is we want to solve this for our y because this is not in slope-intercept form. So we're going to subtract 2x from both sides. Now you're noticing I'm going to actually put that underneath my 0, and that's because there's nothing over there. 0 is just a placeholder, so that side's not left blank. So now we have negative 2y equals negative 2x. And again, you don't have to write the 0. And then we're going to divide both sides by negative 2. So y equals positive 1x. So y equals x. And this is actually our most basic graph. And eventually you'll learn that this is called our parent graph. So when we're looking at y equals x, this is probably the most confused graph just because there's not a lot to it. But it's done the same way. We start by finding our y-intercept. So here our y-intercept is going to be 0, 0. Because there's nothing being added over here. So that means our b, if you were to write the plus 0 over here, right here, our y-intercept would be 0, 0. It starts at the origin. So we're going to start there at our origin, 0, 0. And our slope is an understood 1. There's an understood 1 in front of this x. So our slope is going to be 1. And again, when we have that 1, that means we either have a positive 1 over a positive 1, or we have a negative 1 over a negative 1. So we can go up and right, and we can keep doing this until we run out of boxes. Or we could go down and left, all the way down until we finish it. The more points, the straighter your line, especially if you're like me and you don't have a ruler. So you don't have to do all those points, but the more points, the more accurate. Okay, so number 11, we're going to look at y equals negative x. So again, this one is already solved for slope-intercept form, and again this is another one like number 10 that is easily confused, simply because there's not a lot of numbers with it. But just like the other one, our understood y-intercept is going to be 0, 0, because this is really y equals negative 1x plus 0. So our y-intercept is 0, 0, right there. And our slope is going to be negative 1. So when we go to graph this, again being careful of the negative, this means either the negative is on top and there's a positive 1 on bottom, or there's a positive 1 on top and a negative 1 on bottom. Only one negative when you have a negative slope. So that means we're going to go either down and right, or we're going to go up and left. Okay, negative slope only gets one positive direction. And then we're going to simply draw our line through the points, making sure to put arrows because, again, our domain is understood to be all real numbers. All right, number 12. Y equals negative 7/3 x minus 4. Now, we don't have to solve for y, so that's nice. There's not a lot of work there. We can easily identify our y-intercept. So our y-intercept is going to be 0, negative 4, because it's our constant. And our slope is going to be negative 7/3. So we're going to start with our y-intercept just like before. 0, negative 4, 1, 2, 3, 4, right down there. And again, our slope, the negative either goes to the top and makes the 3 positive, or the negative goes to the bottom and makes the 7 positive. You get to pick. Now, it's important to be able to do either one of these because sometimes one direction doesn't work. So on this graph, if I start at this blue dot and I try to go down 7, I can't do that, and I don't have enough room to go extend the graph. However, I could go up 7. 1, 2, 3, 4, 5, 6, 7, and then that allows me to go left 3. So this is why you need to be able to convert between these different versions, because sometimes you're required to use one or the other because the graph just isn't big enough. And then, of course, as long as we have 2 points, we can draw our line and put arrows on the end. Okay, so that is number 12. Sorry guys, we had a little hiccup there. Alright, so number 13, we're going to have x plus 4y equals 16. So this time we have to solve for y. This is not in slope-intercept form. So we're going to start by subtracting our x term. So that's going to give us 4y equals negative x plus 16. Those are not like terms. Now, when I have a problem like this and I have to divide every term by 4, I like to start by putting a 1 in front of my x because it doesn't have anything, and that's going to help me not mess up my slope, because some people will try to say that that's negative 4x, and it's not. This is y equals negative 1/4 x, and then plus 4. So it's very important that you're careful that you have that number on top of that fraction. This is not negative 4 again, this is negative 1/4. So that means our y-intercept is going to be 0, positive 4, and our slope is going to be negative 1/4. So 0, 4 falls above 1, 2, 3, 4, so on top here. And again, our slope is either going to be negative 1 over positive 4 or positive 1 over negative 4. You get to pick where the negative goes, top or bottom. So if I go from this red point down 1, I could then go right 4. And notice that gives me a downward slope. Or I could go up 1 and left 4, which goes right there. So we don't get to see a whole lot of our graph, but it's still linear. It all falls in a line, so we can tell that this has been drawn accurately. Now again, if you solve your equation wrong, then your graph may be wrong. So it might be a good idea to double check that your points work in the function. Alright, number 14, last one, looks like this. Y equals negative 2x plus 2.5. Now, a problem like this is one of the reasons that maybe using a slope-intercept form isn't the best. This one might be better for a table, and that's because we have a y-intercept that is a fraction. Now, it's not a terrible fraction, but it's still a little messy. So we're going to go ahead and graph it using slope-intercept form because that's what the directions say to do. So our y-intercept is 0, 2.5, and our slope is negative 2. So when we graph 0, 2.5, that means we're going to go up 2, and then we're going to go up a half. So it's right between 2 and 3. And again, 2.5 isn't terrible, but if you had something like, 5 1/8, that would not be very easy to graph. So slope-intercept works when the numbers are nice, but sometimes a table might be more beneficial or intercepts might be more beneficial just because you get nicer points. Now, we're looking again at our slope. So remember, this is negative 2 over 1, which means we can rewrite this as negative 2 over positive 1, or we could let the negative go to the bottom and make that positive 2 over negative 1. So here's where you have to be careful, is with the slope, because when I go up, or in this case I'm going to start by going down, when I go down 2, I'm not going down to this right here. That would not be correct. I have to actually go down an entire step, which means I have to go down to that next halfway point. And then I have to go down again to the next halfway point. And then I go over one entire unit. So that first point ends up being right there. Okay, so then you have to do it again. Down 1 all the way down to the halfway point, again to the next halfway point, and then all the way right 1. Okay, and then I can keep doing this, going to each halfway point and over 1. Or I could go up and over. So again, this is kind of what makes it a little more challenging as far as graphing using those fractions, is simply because then you have to worry about, well, am I getting in the right spot? But you can tell my line is straight. You can tell my slope is consistent. Okay, I'm going down 2 and over 1. And so I'm going to draw my line, putting arrows on each end.